The first blank on those notes is talking about what a quadratic parent function is. We've talked about this before. A quadratic parent function, just like it says in the top right here, this is y equals x squared. That's the quadratic parent function. That's the parent function from which every other quadratic function comes from. Okay, the value in front of the x squared, or the a value that we've talked about before, is just 1. Okay, and that's going to be important today because we're talking about the change of that a value, what changing the a value does to the graph of a quadratic function. Okay, so look at the second blank on your paper. The graph of f of x equals ax squared is narrower, that's narrower than the graph of f of x equals x squared if a is greater than 1. Okay, so I told you that the a value of the parent function is just 1. If it's greater than 1, it's actually going to be narrower. Okay, so it's going to travel inside of the existing quadratic function that we have graphed right here. Okay, the graph of f of x equals ax squared is wider than the graph of f of x equals x squared if a is less than 1. So if this number in front of x squared is less than 1, that means 1/2, 1/3, 0.25, anything like that that's less than 1, it's actually going to be wider. It's going to be wider than the graph of x squared. Okay? And that fourth bullet, the value of a in a quadratic function determines the direction the parabola opens. We've talked about that, how it opens up if it's positive and it goes down if it's negative. Think about this is a big smiley face and it's positive. A big frowny face would be negative. Okay, so negative is down, positive is up. Okay, and I want you to watch this and see this a value right here. It says 1.03. That's pretty close to 1. It's going to be the purple line. As I click this, it's going to show you that as the a value changes, so is the graph of my parabola. As it increases, it gets narrower. You see my a value is getting bigger. Now it's going down as it crosses 1. And you saw very quickly there, now it's in the negatives and it's upside down, but as soon as it gets underneath 1, it gets a lot wider. I'm going to pause it right there. 0.3 is less than 1, so that graph is wider than the graph of the parent function, which is just x squared, in which a is just 1. Okay, so less than 1, it's wider. Greater than 1, it's narrower. Okay, or skinnier if you want to think about it that way. Now, let's look at those graphs. Okay, we're going to compare the graphs of 2x squared, 1/2 x squared, and negative 3x squared to talk about which one is wider, which one is narrower. Now, from what we just talked about and what you just saw in that explanation, the greater the a value, the bigger that number is, the more skinny it is, the more narrow it is. Okay, it doesn't matter. It does not matter if it's positive or negative. Positive and negative only matters, or we're only talking about if it's opening up or opening down with a positive or negative number. So, when we're looking at these three graphs, if you graphed those on a graph, ask yourself which one would be the most narrow. Okay, which one would be the next most narrow? And then which one would be the widest of those three? So the least narrow of those three graphs. Okay, what you should have said is that the negative 3 was the most narrow, okay? That -3, even though it's negative, it's facing down, but it's still the most narrow because 3 is a bigger number than 2. Okay, and what you're seeing right here are absolute value brackets. That means that no matter what is inside those brackets is positive. So this -3, think of it as a +3, just for this part, just for talking about how wide or narrow it is. Okay, the 2 is a little bit less narrow, but it's still very narrow. And 1/2 is going to be wider than the other two. Okay, let's move on to the second example. We've got 3 graphs. You can see them on the screen there. We've got -2x squared. That's the one that's upside down. The frowny face is negative. 1/3 x squared. That's less than 1, so you know it's got to be wider than just a normal parent function, which is 1x squared. And then finally, we've got 4x squared, which is a greater number. It's a big number. That's going to be narrower than our parent function. Okay, so I want you to list those in order, like example 2 asks you to. Okay, what you should have said was that 4x squared was the most narrow graph. Okay, so no matter what, -2 is still narrow even though it's negative. Okay, even though it's upside down, it's still narrow, but 4 is a bigger number. So 4 is more narrow than -2. -2 is still narrow. It's more narrow than the parent function. And 1/3 is by far the widest of those 3. Okay, so when we're talking about, again, we're talking about how wide or narrow those graphs are. When we're just talking about wide or narrow, it does not matter if it's facing up or down. Okay, if we ask, is it positive? That means it's facing up. If it's negative, it's facing down. Okay, now take that information and apply the exact same principles to your homework assignment. Be good.